Hello students, how are you all? I hope you are doing well. So welcome all of you at AriserTalent. I'm your physics teacher Krina, welcomes you all. So AriserTalent is basically an online learning platform where you can get the courses you are desired for. Whether it is from CBSE, NTSE, JEE and NEET, you will get the entire content from the expert faculty of Kota. So what you have to do, you have to just subscribe our channel to get the latest updates and the content you are searching for. So in AriserTalent, apart from the very good content that is made by the expert faculties of Kota, you also get the problem solving and the test series you are desired for. So after completing your chapter, if you want to analyze yourself, you must solve the test series, but after the completion of that part. So for all that study material you want, you have to subscribe our channel and you need to get the latest updates of that videos. So just subscribe our channel and enjoy our videos. So in our last lecture, we have discussed about the magnetic effect of electric current. In our today's lecture, we are going to deal with basic NCERT questions that are from your exercise of NCERT book we are going to discuss today. So let's discuss the questions here. First question in this sequence we have: which of the following correctly describes the magnetic field near a straight wire? So you have to determine the magnetic field due to the straight wire. So the options here are: field consists of straight lines perpendicular to each other, field consists of straight line parallel to each other, field consists of radial lines originating from the wire, and the field consists of concentric circles centered on the wire. So due to a straight conductor, the magnetic line of force are actually the concentric circles, and the center of this circle will going to lie on the length of the wire. So among all these options, the correct option is option number D. Because due to the straight conductor or straight wire, you will get the magnetic field lines that are the concentric circles. So our option number D is correct here. Now let's move to the next question in this sequence. The phenomena of electromagnetic induction is. So what is electromagnetic induction? This topic we have discussed in our chapter, that electromagnetic induction is basically a process when magnetic flux linked with the coil changes, there will be the induced EMF in the circuit. So the options are: it is the process of charging a body. This is a wrong statement. Process of generating magnetic field due to the current passing through a coil. Producing induced current in the coil due to the relative motion between magnet and coil. The process of rotating the coil in an electric motor. So it is actually a process of inducing the electric current, and electric current is induced only when there is a relative motion between magnet and coil. So which option is correct here? Here option number C is correct, and it is actually the definition of electromagnetic induction. It is your definition. So we can see that option number C will be correct here. Now let's move to the next question in this sequence we have. The device used for producing electric current is. So you have to determine the device which is used for producing electric current. So ammeter and galvanometer are actually the apparatus which is used to detect the strength of the current. But the device which is used for generating the electric current, it means the device which is converting mechanical energy into electrical energy, is only generator. So which is the correct option here? So our option number A is correct, that is generator. It is used to convert mechanical energy into electrical one. Now the next question in this sequence is: the essential difference between AC and DC generator is. So you have to determine the difference between AC and DC generator. So one difference we have seen in AC and DC generator is that about the rings we have taken. The rings in case of AC generator are the complete rings, but in case of DC generator we have the split rings. It means we call them as a commutator. So let's read the options first so we can analyze the correct option. AC generator has an electromagnet while DC generator has a permanent magnet. This statement is absolutely wrong because both of these consist of the strong permanent magnets. DC generator will generate higher voltage. This is again wrong. AC generator will generate higher voltage. This statement is again wrong. AC generator has a slip rings while the DC generator has a commutator. So this is the correct option which is matching to our conditions that in AC generator we have a slip rings, but in case of the DC generator you have a commutator and this is known as split rings. So which option is correct here? Option D is satisfying the conditions. So I can say that option number D is correct. So now let's proceed to the next part of the question you have. At the time of short circuit, the current in the circuit. So whenever there will be a short circuit in your device, what will happen? The current will reduce substantially, does not change, increase heavily or vary continuously. So if there is a short circuit, it means you are running many of the devices, and in that case, the current will substantially increase. So the correct option is current in the device will increase heavily. So which is the correct option here? We can say that option number C is correct. Now, let's move to the next question in this sequence we have. You have to identify which statements are true and which statement is false here. So this is basically our true and false. So I'm reading the first question here. Electric motor converts mechanical energy into electrical energy. So is it happens? So this is not happening. Why? Because electric generator will convert the mechanical energy into electrical energy. That's why we are running all the electrical devices. But in case of electric motor, electrical energy will be going to convert it into mechanical energy. So this statement is true or false? This statement is false here. This statement is false, and why it is false? Because electric motor will convert mechanical energy into electrical one. In this case, mechanical energy will going to be converted into the electrical one. So this will be our answer. Now let us move to the B part we have. Electric generator works on the principle of electromagnetic induction. So this statement is absolutely correct. Electric generator is working on the electromagnetic induction. It means when the flux linked with both the coils change, there will be the induced EMF in the circuit. That is about the definition of the electromagnetic induction. So this option is correct here. So I can write here this statement is true. Now, third part is the field at the center of a long circular coil carrying current will be parallel to the straight line. So this topic we have also discussed in our lecture that in a current carrying coil, if you want to determine the magnetic field lines at the center, what you will get? You will just get the straight lines at the center, and in the corners you will get the circular pattern. So it is absolutely true that in the middle part you will get the straight lines. So again, this statement is true. Now let us move to the next part. A wire with green insulation is a live wire of an electric supply. So is it true? This is not true because the green insulation is always provided to the earth wire. Live wire will not have a green color. So this statement is absolutely false. And why it is false? Because green color is provided to our earth wire. You have 3 wires in the domestic circuits. So the green color will be of the earth wire. So this is about the true and false. So let us move to the next question in this sequence. List 3 sources of magnetic field. Can you tell me what are the 3 sources of the magnetic field you have? So, we have the 3 sources of magnetic field and these sources are, one is permanent magnets, from that you will get the magnetic field. Second one is electromagnets. Electromagnets will always going to give you the magnetic field. And third one is you have a current carrying conductor. So, actually these are the 3 sources from you can get a magnetic field. These are permanent magnets, electromagnets and the current carrying conductor. Now, let's begin with the next question here. How does a solenoid behave like a magnet? Can you determine the north and south pole of a current carrying solenoid with the help of a bar magnet? You have to explain it. So, if you see that we have seen the magnetic field lines due to a solenoid. So, solenoid is actually a cylindrical piece of conductor on which the windings are done of the copper wire. So, the number of turns of the copper wire has been done on the long cylindrical rod. So, this will give you a solenoid. Now, if I want to determine the polarity, it means if I want to specify the north and south pole, what I will do? I will just take a magnet near the north pole. So, the north pole of a magnet, if connected to the positive terminal of a battery, it will going to repel each other. If it is going to repel each other, we can easily identify that the south pole will give you the negative terminal and north pole will give you the positive terminal. So, this is how you can justify whether north pole and south pole can be analyzed or not. So, a solenoid is actually a long straight piece of conductor on which the number of insulation of copper wires have been done. So, it will be connected to battery and there will be key. Now, the magnetic field lines due to this solenoid will be actually just like the bar magnet. And its direction will be like this. So, this is how the magnetic field lines due to a solenoid can be made. Now, if I brought the magnet near the positive terminal of a battery, this is my magnet and this is having a north pole and this is having a south pole. If I brought it near the positive terminal of a battery, then what will happen? It will going to repel each other. It will going to repel each other. Then what will happen? We can easily identify that if positive terminal of a battery is going to repel this north pole, it means in that magnet N will be your negative and S will be your positive terminal. So, this is how we can get the idea about north pole and south pole in a bar magnet. So, this is all about the magnetic field lines due to a solenoid. So, this is the correct solution here. Now, let's move to the next question we have. When is the force experienced by a current carrying conductor placed in a magnetic field largest? So, this is a very interesting question you have, and this force will be given by Bill sin theta. So when will be this this force in the current carrying conductor maximum? This will be maximum only when theta equal to 90 degree, because sine 90 will give you 1 and you will get the value of force here, that will be BIL sine 90 and it will be equal to BIL. So you can see that when the angle is 90 degree, you will get the largest value of the force. It means the magnetic field is perpendicular to the direction of the current. We can see that force experienced by the conductor will be maximum. So what is the correct answer here? Magnetic field will be, magnetic field must be perpendicular to the direction of current, and in that case only the current will be, force will be largest on a current carrying conductor. So this is our right answer. So just copy this part from here. This is a very interesting question you have. Now let us move to the next question in this sequence we have. Imagine that you are sitting in a chamber with your back to one wall. So you must be sitting like that, your back to the one wall. Now, an electron beam is coming horizontally from the back wall towards the front wall. It means, what are the given conditions here? The given condition is that electron beam coming from back to front. If electron beam is coming from back to front, we can say that what will be the direction of current? The direction of the current will be from front to back. It will be just opposite to that of the electron beam. So I can say that direction of current from front to back. So this will be your direction of current. Now, if it is deflected by the strong magnetic field to your right side, deflection is in the right side. So I can say that the motion or the force will be in right side. So what will be the direction of force? Force is in right side. Now, what will be the direction of magnetic field in this case? So you have to determine the direction of magnetic field here. So now if I am going to apply the Fleming's left hand or right hand rule, what I will get here? This thumb will give you the direction of force. This finger will give you the direction of, forefinger will give you the direction of field, and this finger is going to give you the direction of current. Now the current is coming in such a way, that current will be from front to back. It means my this finger, index finger, is coming from front to back. And what is the direction of the force here? Direction of the force will be like this. It is like this. Now, you have to identify the direction of magnetic field here. So, if I keep my fingers like this, you can see that current is coming from back to front. Current is going from front to back. So I have to rotate this finger like this. This is like this. Current is going from front to back, and this magnet, this will give you the direction of force, and force is in the rightward direction. So if I orient my fingers in such a way, so it will be a bit difficult. You can analyze or imagine and visualize, like assuming it in your own fingers. So I'm taking my this hand. So what I will do here, current is coming from front to back and magnetic field is going here. So it will be like this. This finger will be rotated in this direction, and you have to analyze the direction of the magnetic field. This is actually like this. So if I'm going to orient my fingers in such a way, I will get here the direction of the magnetic field in this case will be upwards. it will be upwards. How it is upwards? Let's imagine that current is going from front to back. This is the direction of magnetic field. So this is the direction of the force you have. So I have to keep my finger like this to keep them mutually perpendicular to each other. So what will be the direction of magnetic field here? The direction of the magnetic field in this case will be upwards. So these are some of the questions from your NCERT. We will deal with many more questions in our next lecture. Thank you so much and have a nice day.